Hello, dear listeners. My name is Natalya Leonidovna Istomina. I am an employee of the Russian Academy of Sciences, a professor. I lecture at the Moscow Aviation Institute. I teach the course Innovations and Development of Industrial Technologies. Today we will talk about the future, about what industrial industries await us in the very near future in 2100. So, what awaits us in the near future? What kind of industry will be in the future in which you and I will live? In general, is it possible to predict our industry? Is it possible to make plans? What is the planning horizon? It is known that a child under the age of 13 cannot plan anything further than one day. When you get older and from up to 25 years of age, the planning horizon is 1 month. From 26 to 45 years of age, the planning horizon is 5-10 years, and only from 46 years of age and up to the active age of 65 years of age, the planning horizon is 25-30 years old. That is, people with experience and life competencies can predict the future that will come, well, in the next 25-30 years. Of course, there are forecasting errors. When Henry Ford organized a car assembly line, humanity was using horses at that moment. If I asked my clients what they would like, they would say it's a faster horse, but Henry Ford offered his customers a fast car. Predictions about horses, their speed, and street cleaning after the horses drove along the roads of the city were wrong. On the other hand, we know the great French writer, whom we have been reading with you since childhood. In his works 20,000 Leagues Under the Sea, Captain Nemo, 15-year-old captain, he gave a forecast of the industry of the future. These were submarines, airships, and, as we are now convinced, 150 years after the moment of writing these works, the forecasts took place. There is a famous Russian writer, Alexei Tolstoy. He wrote the novel Hyperboloid by Engineer Garin. There was such a villain, Engineer Garin, who invented a powerful light beam and used this beam to destroy factories. It was fantastic. But again, 100 years after writing this novel, physicists are using a powerful laser beam to light a sodium star in the sky. This is an artificial star that serves as a reference point for space research. In general, humanity likes to predict. There's a well-known company that releases a technology development forecast every year. They are building a so-called Gartner curve, which is the name of the company. This Gartner curve shows which technologies are on the rise. From which technologies are expected, explosive interest and large production volumes are literally expected. This is the so-called peak of inflated expectations. But then there is disappointment, because the forecasts did not come true. And after many years, this technology reaches a plateau, because it is gaining popularity. People, engineers, and specialists understand this technology. This is the so-called growth of enlightenment and productivity plateau. There are traditional types of industry, those types of industry that accompany a person from the beginning of his life. Many millennia ago. This is metalworking, this is fruit picking, this is fabric production, and although the tools are changing, we have a laser instead of a drill, the traditional types did not change. This is industry, this is agriculture. This is a light industry, fabric production, but tools are changing. Let's look at the development of the engineering industry from the 18th century to the present day. When steam engines appeared, they replaced human labor. It has become easier to extract minerals, it has become easier to process materials. When electric machines appeared, and this happened after the fundamental laws of physics in the field of magnetic and electric fields turned into machines and mechanisms, the era of mass production began, and then the production of goods began to occur in huge quantities. In the 20th century, mechanization of production took place, programs written for computer systems appeared, robots appeared, and this allowed to reduce the cost of production, and nowadays a new trend has appeared, new technologies have appeared. Machine learning, artificial intelligence. And all this made it possible to automate the exchange of information and even make decisions. That is, the mechanical engineering industry has entered a phase when cyber-physical systems make it possible to free a person from making decisions, from mistakes. In general, interaction and decision-making are at the machine-machine level, eliminating human errors. Therefore, we strive to transfer our functions to robots and machines. That is, there are cyber-physical systems, these are big data, autonomous robots, digital twins. We'll talk about them, digital doppelgangers. And at the same time, we have additive manufacturing, we have the industrial Internet of Things, which allow us, connecting into one system, to make decisions based on that experience, on the basis of those libraries that are embedded in the software. For example, digital doubles. What is it? Here we have an oil refining plant. There is an operator who monitors the function of this plant. It is much easier if we build a model of the plant with you. It will be the so-called digital twin of the oil refining plant. And then, in this digital double, we consider the state of a complex technical facility, like a factory. We have detectors for the operation of industrial installations, and as a result, you and I receive data from the detectors that such and such a node is in good condition, his status is okay. And some node has gone beyond the operating conditions. This immediately gives us a signal to the operator that we need to make some decisions. But these decisions are already embedded in the decision-making library. This is how the method of using digital doubles works. Another new area of technology is the so-called addictive technologies. They appeared only in 1996, they are developing. But for which products do we need additive technology? This is necessary for products with a complex design. For example, engines for racing cars. It is impossible to process and create such a complex structure using any traditional mechanical methods. Or another example is rocket engines. To get the satellite into orbit, we have to launch a rocket with you. The rocket should be as light as possible in order to put a satellite with scientific equipment into orbit. This means that rocket engines must be light, durable, and heat-resistant. Such constructions can be obtained only with the help of additive technologies. Or in construction, transparent concrete is obtained using additive technologies. This is a new building material that allows you to create new beautiful images of the architecture of the city. And depending on the light that is inside these buildings, we get beautiful images of cities and houses. But we are talking about robots replacing manual labor. Tell me why. You are a responsible person. He approaches his work carefully. Well, the young man on the right is smiling. Maybe he talked to a girl, he is pleased, he has thoughts and, bang, he made a slightly wrong step, and the product of his emotions was made with a mistake, and robots are devoid of emotions. Robots work only according to the program that contains all the working conditions. But this program was created by a human. That is, robots replace manual labor. Where robots can work, and where you can't do without a human. There is such a concept in the industry, single production. When one element is made, one product in mass production are products that need a lot, that go into series, and here are different conditions, different requirements for their production. In mass production, we use robots, and in single production, for example, a telescope that observes cosmic bodies. On the next slide, you and I will see how the telescope is assembled. You can see how many people manually assemble mirrors of such a complex hexagonal shape and make up a telescope mirror from these mirrors. That's where manual labor is needed, where high quality is needed, and, let's say, bearings or devices that reduce friction in mechanical structures. They are made as a mass production. Another example of an individual production, where robots will never be used. Then our telescopes observe cosmic bodies. They don't see them in such a beautiful way as we are used to. The telescope gives us a picture as blurry as in the lower right corner. The laser beam that we talked about at the beginning of our conversation ignites an artificial star in the upper atmosphere, a sodium star, and observes this star. At the same time, the atmosphere experiences fluctuations, the air flickers, dust particles sweep through the air, and instead of the halo image, we see such a blurred image. Therefore, to the telescope, which is like this to the mirror of the telescope, which is so carefully assembled by an employee, we attach such pushers from behind. These pushers push small mirrors, distorting the shape, but corresponding to the shape of the air fluctuation, and then we get from one picture with you such a beautiful picture. And then we see how our stars are arranged. We see how they move, the planets move around them. And so that the stars do not flicker, special adaptive optics are needed. This is a new technology, and they will develop, because humanity strives to explore the cosmos, strives to explore the cradle of our universe. New technologies have also entered the agro-industrial sector. It turns out that we can speed up the ripening time of fruits. If we simulate with you with the help of light, we will simulate day and night, that is, you and I will create some kind of factory where artificial light will allow us to accelerate day and night. We will be watching the tea plantations with you. We will launch unmanned aerial vehicles with you, on which we will attach technical vision lenses with you, and we will look at the condition of the leaves, where fertilizers need to be added, where medicines need to be applied, where watering needs to be carried out. Here is an example: robots are watching the growth of lettuce. There are still new technologies, how to protect plants from diseases. If you illuminate pathogenic bacteria that parasitize plants, you will illuminate with light, then you can suppress these bacteria and lead to their destruction. How do we achieve this light? We are creating a so-called device, light-emitting diode LEDs. Put together, these LEDs create filaments for us. These LEDs create for us such a celebration of the soul, that is, light is life. New technologies are developing with the advent of photonics in our lives. Now let's look at the global trends in pharmacology and medicine. Global trends are the observation of the human condition, that is, biomonitoring. A person's blood circulates, his skin breathes, the color of the skin changes. A person has a lot of things in the body that we can observe. This means that we create different sensors with you, and we attach them to a person and can judge his state of health, prevent any accidents. At the same time, according to a person's condition, we can determine his intentions, what he wants. If the girl in our example approaches the bank with a calm face, then, of course, no one will suspect her hacking, the same person who planned to carry out the robbery. His pulse will change, his complexion will change. And here hardware solutions, robotic automated solutions will prevent the onset of dangers, will prevent the threat. In general, modern industrial technologies strive for circuit solutions. This is when you and I have a sensor, but we must definitely attach a mathematical description to it. Mathematics is the language of life, it is the language of the universe, it is the language of nature. Knowing mathematics, you create software for sensors, for detectors. And when you receive a signal from a sensor, you pass it through a mathematical model. As a result, you get data on the technical condition of a complex object. And then artificial intelligence, which is based on your methods and on libraries of solutions, will decide what to do in this case. This is the trend of change in traditional industries. But what are we striving for when building a new industrial society? It is known that the circulation of substances in nature occurs, and what is created in nature, the internal energy of the earth cyclically passes into sedimentary rocks, into energy accumulation. That's exactly how naturally similar technologies should prevail in the future. There must be responsible consumption and production. You cannot produce as much as possible. It's not going to do any good. The disposal of those items that have been produced must be provided for. There must be responsible consumption. That is, if you and I produce energy with the help of a nuclear power plant, we transfer it to energy consumers, we transfer it to factories, we transfer it to factories, and we transfer it for consumption by residents. The most important thing is sustainable development. You know that the United Nations has developed 17 basic principles for the sustainable development of life on our planet Earth. We must ensure reasonable consumption of energy and material resources. All this should return back to nature, and then we will have a sustainable development of our civilization. Therefore, it is up to you to decide what the development of the industry will be in 2100. You will think about it more competently and will look at it with an experienced eye, probably in 10 years. In the meantime, life starts today, and you need to learn to make decisions. Good luck and see you later.